Hello and welcome. I am back with part 2 of our activity 5.1 video. It's a little scary that this activity has to take 2 parts, but it does have a lot of questions and not necessarily a ton of new stuff for us, but it does have a lot of practice and a lot of distance formula, which does take some time. Plus, I like to talk a lot on these YouTube videos. That's one thing that's nice about these as opposed to class. I can talk as much as I want, and you can just fast forward if you'd like, unlike in class when you have to sit there and listen to me talk and talk and talk. Anyway, here we go. So part A, we're looking at question 9. Part A, determine the perimeter and area of this quadrilateral. Round your answer to the nearest hundredth if necessary. Okay. So the first thing I'm going to do, so the proper way we want to do this is to do this distance formula for each side and add those up in order to get the perimeter. The first thing that I want to do is actually to write some ordered pairs for these points. And the reason I do that is because when we do distance formula, we're going to want some ordered pairs. So L is at -8, -4. M is at -20, -10. Okay. N is at -8, -16. And O is at 4, -10. All right, so now I'm just gonna move this shape out of here, and we're gonna do some distance formula, okay? I didn't give myself a ton of room, here we go. Okay, so we need to know the length of all 4 of these sides, our 4 sides being LM, MN, NO, and OL, okay? So for the first thing, what we're gonna do, we need to find the length of LM. So this length is going to be, remember this distance formula has this long square root, and we're gonna do x2 minus x1 squared plus y2 minus y1 squared. So I'm just going to go ahead and do m as my x2, y2, and x1, y1 right here. So that means that I'm going to have -20 minus, minus a -8 right there, all of that squared, plus a -10 minus a -4, all of that squared as well. So we have 20 minus a -8. And if you all remember, subtracting a negative is the same as adding a positive. So -20 plus 8. I'm just going to do some simplifying here. -20 plus 8 is the same as -12. We still need to square that. Plus -10 minus a -4 is like -10 plus 4. So -6, all of that squared. Okay. So now we're right down here. I have 144 plus 36. That's equal to the square root of 180. Now on my handy dandy calculator, I'm going to do the square root of 180. I get 13. I'm off the screen, not quite. Okay, 13. I apologize for that. Gross 3.42. Okay, so that is the length of side LM, of line LM. Okay, so now I got to do this 3 more times, which I know is super gross, but we will see a little bit of a pattern, and we might not need to do all of it. Okay, so now I'm going to do MN. Again, this long square root, so now I'm doing a different side. So again, I'm just going to go, so I'm going to do the second one as my x2, y2. So last time I did x1, y1, x2, y2. This time I'm going to go x1, y1, x2, y2. So I'm going to have -8 minus a -20 squared plus -16 minus a -10 squared. Okay, so that means that my -8 minus -20, so when you subtract a negative, it's like adding a positive. So that means I'm going to have +12, -8 plus 20 is +12 squared, plus -16 minus -10 is like +10, so -16 plus 10 is like a -6 squared. Okay, so now I'm going to have 144 plus 36. This looks an awful lot like our last one, the square root of 144 plus 36, which is the square root of 180, which is equal to 13.42. Okay, I'm going to save us some time and tell you that if you do the distance formula for both side NO and the side OL, you will get the same side length. Okay, so this does happen to be a square. All of our side lengths are the same. Okay, so that means that coming back onto our packet now, okay, we're on part A. It says determine the perimeter and area of this quadrilateral. We said that all sides have a side length of 13.42, and perimeter is equal to the distance around a shape. So since there's 4 sides and all of our sides are equal to this, that means that my perimeter is going to be equal to 13.42 plus 13.42 plus 13.42 plus 13.42, going on to the graph now. Okay, that's a really expanded way to write it. You can also just say 13.42 times 4. Okay, so that, again, handy dandy calculator, that is equal to 53.68, so our perimeter is equal to 53.68. Okay, so now our area, the nice thing now is that since we know this is a quadrilateral, since we know that this is a square, okay, our area is equal to base times height. The nice thing about a square is that because all of our side lengths are the same length, doesn't matter which one's base, which one's the height, they're all equal. So my area would be equal to 13.42 times 13.42. Okay, and 13.42 squared, or 13.42 times itself, is equal to 180.096. Now this says that we need to go to the nearest hundredth, which if we're talking about money is like the nearest penny. So 0.96, I would round up. That 9 would become a 10, and then I would add 1 to my 10th spot. So this would be 180.1 for my area there, okay? Perfect, so now I'm gonna double the side lengths of this quadrilateral, L, M, N, O. How does this affect the area? What are the new coordinates, okay? So I'm gonna be on there's one from our last video here, okay? I'm going to draw this. I'm gonna go 1, 2, 3. So here's our shape, approximately, okay? Now it says double the side lengths. So I'm gonna go like this. Okay, and I'm drawing it this way for a reason, okay? So here's our original shape. Okay, here's our original. And now we doubled both the side lengths. So I doubled this side length to get to here. So if we're talking about base and height, again, it's a square, so it doesn't matter which is which. I doubled my height, so now I have 2 height, and I doubled my base as well, and then I connected all of those, okay, with parallel sides, 90-degree angles, all that good stuff. The stuff that makes a quadrilateral a square. So that means that our area of our original shape was base times height, and now for our new shape, it's equal to 2 base, remember base and base, times 2 height, height and height. So the way we can another way we can write this, 2 times base times 2 times height, which is equal to 2 times 2 times base times height. Because remember, multiplication doesn't matter what order it's in, we can do that. So now that means I have 2 times 2 is 4, so times base times height. And then last step, I can rewrite this as 4 times base times the quantity base times height. And so since our original was base times height, that means that our new area, okay, this new just drops all the way down, so our new area is equal to 4 times our original area. So going back to our question, double the side lengths, how does it affect the area? What are the new coordinates? Okay, so how does it affect the area? Area is quadrupled. Okay, and then our new coordinates, I'm going to go ahead and just draw it up here. I didn't the first time because I didn't want to run into my 13.42 craziness, but I forgot that I needed to do this, so here we go. And that point doesn't need to be there. So our coordinates for our new, what are the new coordinates? Okay, if I make this, so we'll say that this is n, so n doesn't change, you can leave that one, but O prime, L prime, and M prime, we want to label those. So O prime would be at 16, -4. L prime, oops, sorry, off the screen a little bit, would be at -8, 8. And then M prime would be at -32, -4. Perfect, so those are our new coordinates, okay? C says describe how you could translate quadrilateral LMNO to make the perimeter and area calculations more efficient, okay? So really fast, more efficient means easier, less work that's required, okay, all that good stuff. So the important thing to remember here is that we are translating it. So we said in our last video that a translation is a slide. So that means that I want to take this original shape, and I want to slide it to make my job easier. So that doesn't mean I can't rotate it. We're not rotating. We're not reflecting. We're not folding our paper. Okay, we're literally just gonna move it up. We're gonna move it to the right. We're gonna move it up, move it to the left, move it down, right, left. Okay, we can do all those things. There is a lot of different ways you can answer this. So if you really like working with negative numbers, you really loved this problem. There were a lot of negative numbers, okay? When we were doing those distance formulas, a lot of negative numbers, kind of gross, I think. But if you like those, perfect. This is actually in a pretty good spot for you. If you don't like negative numbers, if you'd like to work with positive numbers, a way that we can move this to make this easier for you is we can move it up, okay? So what I'm going to try and do, my objective is to get it so all of this shape is in quadrant 1. If you'll remember, quadrant 1, quadrant 2, quadrant 3, and then quadrant 4, okay? So quadrant 1 has all positive numbers. So if I can get this shape, our original shape, all the way, or all completely in quadrant 1, that would mean that I have all positive numbers, okay? So one way that I could do that, if I move this up 1, 2, 3, 4, 5, 6, 7, 8, if I move this up 8 squares, so my translation, okay, let's say I move it up 8, okay, so that puts n right here. And then if I move it over 1, 2, 3, 4, 5, so then I move it to the right 5, that means that my shape is going to be right here. So this will be n, and I'm going to go 1, 2, 3. And you can see now that our new shape, if I were to translate it up and over like that, would be all in quadrant 1, which would make all of our calculations much, much easier. Okay, so that's part C on that one. Now we are looking at number 10. Consider triangle DEF with these vertices. Determine the perimeter and area of DEF. Round your answer to the nearest hundredth if necessary. Okay, so one thing that I said earlier, a perimeter is the sum, or if we add up all of our side lengths, that is our perimeter. So the nice thing about lines that are horizontal or vertical, perfectly vertical or perfectly horizontal, okay, is that we can just count squares. So I'm going to say from DF we have 1, 2, 3, 4, 5, 6, 7, 8 squares. It's 8 squares long here, and then this is 1, 2, so it's at a half, so up 1, 2, 3, 4 squares. Okay, and then the thing we need to be careful about, similar to our rectangle from the last video, okay, is how much each of these squares are worth. So from 0 to 2 is 2 squares, that means every square is 1. So from left to right, we're good. 8 squares is 8 units. We need to be careful though, because on our y-axis, each square looks like it's going to be 2 units. So these 4 squares are actually going to turn into 8 units. So even though these two lines do not look equal, the way the axes are labeled make them equal in value. So 8, one side of 8, one side of 8. Okay, to find this third side, because these are horizontal and vertical lines, we know that they're perpendicular. So we can do some Pythagorean theorem to determine this last side length of DE. So I have 8 squared plus 8 squared is equal to c squared, and c squared is going to be, here's our side c, okay? So 64 plus 64 is equal to c squared. 128 is equal to c squared. The square root of 128 is equal to c, and so that is our side length. Handy dandy calculator, 128. Okay, so that means that this is going to be 11.31 is equal to this. So that means this side length is 11.31. So now our perimeter would be adding all of those things together. Okay, so now coming over here, our perimeter is going to be equal to 11.31 plus 8 plus 8. Okay, I know that 8 plus 8 is 16, plus 11.31 is 27.31. You can check my mental math if you want with a calculator, or you can just trust me. Either way, good to go, okay? If you do catch a mistake in these videos, I will definitely give you some extra credit. It means that you're watching them, you're spending time on it at home, or in addition to my instructions. So definitely will do that. I'll see if anyone comes to me with questions for extra credit. Anyway, so now we want to do the area as well. We said that the area of triangles is 1/2 base times height. All right, so we have base, our base here is 8, our height is also 8, so our area is equal to 1/2 8 times 8. Okay, so 1/2 times 8 is 4, times 8 is 32. So our area for this triangle would be 32. Our perimeter is 27.31. Okay, now we look at part B, double the height. What are the coordinates of the new triangle? How did this affect the area? Okay, so if I double the height, it was 4 squares tall, so now I'm going to go up 4 more, 1, 2, 3, 4. Here's my new point, and then I can go ahead and connect this. I'm going to do it with a dotted line so I don't draw through my 11.31. Okay, so what are the new coordinates? D and F stay the same. Our new E, our E prime, okay, would be up here at 3, 6, 7. So yeah, it'd be at 3, 7. So we'd say E prime is at 0.37. And then how does this affect the area? Similar to our rectangle. Okay, we said our rectangle, if we double the height, it doubles our area. If we double the base, it doubles our area. If we double both of them, it quadruples our area, because that's like doubling a double, or 2 times 2, which is 4. Okay, so instead of showing you all of that, because we've talked about that a few times now, doubling the height of a triangle is going to have the same effect as doubling the height on a rectangle. So how does this affect your area? It doubles it. Okay, so similarly down here, double the length of the base. What are the coordinates of your new triangle? How did this affect the area? Okay, so our triangle is 8 long. Unfortunately, we can't, well, there's not enough room to go over. There's a couple ways you can do this. Because you need to add 8 units, you could go 4 this way, 4 that way. What I'm just going to do is I'm actually just going to go 1, 2, 3, 4, 5, 6, 7, 8. This is an approximate, okay? This is an approximation that was about 3 squares extra. Okay, so I went over 8, and then I would connect this to this point over here, which is going to make a really skinny, really long and skinny triangle. Okay, you can kind of see that it would be this super long and skinny one. Okay, so double the length. What is this new point? So this, our D was at -5, -5, -9, and so because I went directly over, I went to the left, this line is horizontal, it's still going to be at -9. So my D prime, its y coordinate is going to be -9. And then I went from -5 to the left 8, which would put me at -13. So that would be that new coordinate there. And these other two, because we didn't change our height on this one, on this particular change, okay, it wouldn't, points E and F would not change. So this is our only new point, which is the only one you need to list. And again, just like we doubled the height of a triangle, it doubled the area. Just this is going to be the same thing here. We double the length, it doubles our area. And it being the area, because it says how does it affect our area, it doubles it. Okay, so now it says double the length of both base and the height. How does this affect the area? So similar to doubling both sides of a rectangle or a square, it's going to double. So it'll be, if we have our original, it'll be 2 times our original for doubling the length, and then it'll be 2 times the original for doubling the height. So 2 times 2, it would be 4 times the original for doing both. Okay, so it would quadruple that. Okay, now we're looking at number 11. This might need to be a 3-part activity, which is gross, I apologize. Okay, but I do want to make sure to hit all of this for you guys. So 11 says, Mr. Young gives his class this same triangle, same one that we were just working with, and asks them to determine the area and perimeter. 4 of the students decide to first transform the figure and then determine the perimeter and area. Their translations are shown. So you can see Michael's triangle here, Angelica's here, Juan has his beautiful triangle here, and then Isabella her beautiful triangle as well. Okay, so now I'm going to look at this next part. So this is still question 11. It says describe the transformations each student made to triangle DEF. Okay, so quick reminder, here was DEF. Okay, so now we want to see how each student translated those. So it looks like Michael's is taller or higher up on the coordinate plane than the original one. So I would need to know how much. So it looks like this point F here is at 3, 0, right? It's at 3 on the x-axis, and it's not off of the y-axis at all, so it would be at 3, 0. But in our original, F was at 3, -9. So it looks like in order to get from 3, -9 to 3, 0, like here, that means that Michael would have to move his, Michael would need to move his up 9. And that is a translation. Okay, so he moved it up 9. Now we're going to talk about Angelica. Okay, we know that Michael moved his up 9 to get it to look like this. It looks like Angelica, hers looks a lot like Michael's, only it's scooted over to the left a little bit. So we can say safely that she moved up 9 as well, but she also moved it to the left, and so we just need to know how many. Well, this point F is at 3, 0, and this point F is at 0, 0. So to get from 3 on the x-axis to 0 on the x-axis, we need to move to the left 3. Okay, so there's Angelica. Now we're going to look at Juan. okay? So Juan's triangle is down here. It does look a lot like Angelica's triangle. If I were to fold this piece of paper, right, and move Angelica's triangle over that y-axis, it would look very much the same. So for Juan, I'm going to say he did the same thing as Angelica, and then he did those two things, and then he reflected over the y-axis. So he then reflected his shape over the y-axis. Remember, reflection is like if you fold your paper, okay? So I'm again at the 20-minute mark. I'm going to go ahead and finish this problem, finish parts B and C, and then I will wrap up this video and give you guys a third part for 5.1 as soon as possible. Okay, so here we go. Part B, whose method do you think is most efficient? Explain your reasoning. So this is an opinion question. There are no wrong answers. If I were answering this, Mr. McGill's humble opinion, okay, I got these 4 triangles here. Oh shoot, we forgot to do Isabel, my bad. So Isabel, how did she change her triangle? Okay, so if she, if we look, so her point F is at 0, -8. And again, the original point F was at 3, -9. So to get, so here, 3, 9. So this is our original, this is our new one. So she had to move this to get from -9 to -8. She had to move it up 1. And then to get it from 3 over to 0, so 3 our original over to 0, she would have had to move it to the left 3. Okay, and that's all that she did. So now part B, whose do you think is more efficient? Personally, I like working with all positive numbers. Again, we talked about on the last one how quadrant 1 has all positive numbers. So that reason alone makes me think that Juan's is in fact the best. Again, this is an opinion question. It says, which do you think is most efficient? Explain your reasoning. As long as you can explain, okay, as long as you can explain whoever you pick, there is no wrong answer on this one. So go ahead and throw down whatever you feel. Okay, so part C, what do you know about the perimeter and area of all these triangles? Explain your reasoning. Okay, so I want you to remember, so actually here, let's come up here. What kind of transformations do? We did translations, we did a lot of translations, and we did 1 reflection. Okay, so the thing that we talked about translations earlier is that they don't affect size, they only affect position, which means that they do not change perimeter or area at all. Okay, well, what about reflections? Do reflections change size? Well, we said that here's Angelica's triangle, here's Juan's triangle. We said that that was a reflection, and they look pretty similar in size to me. And to save us some time, because I am already over my time, okay, I'm not going to calculate that out, but I can guarantee you that those are both the same area and perimeter. So that means that translations don't affect size. That means that reflections don't affect size. They only affect position. So that means that all of these things down here, sorry, part C, that means that all of these shapes, okay, have the same area and perimeter. So what do you know about the area and perimeter of all these? They are all the same. And then explain your reasoning for the reasons I just said. Translations and reflections don't affect size. They only, cannot spell, affect position. Okay, there you go. So this was part 2 of apparently a 3-part series on this 5.1 activity. I apologize that this is taking so long. Like I said, the YouTube videos are nice because I can go slow. It also is a little unfortunate because 60 minutes of YouTube videos are not the best. Like I said, I will have timestamps on all of these questions down at the very bottom. So if you just had to look at question 11, this one that we just did, you can go ahead and click that as you need. Anyway, hope you guys have a great day. I will see you later in class. Have a good one.